Some probability questions will ask you to find the probability of at least one, and at least one is the equivalent to one or more. So the complement of getting at least one item of a particular type is that you get no items of that type. Okay? So if you need to find the probability of at least one, take one and subtract the probability that you don't get any. So we actually have two different formulas here, and we have the two different formulas set up in case it's dependent or independent. Now, if we have dependent events, we're going to take 1 minus the probability of none, and when you're finding the probability of none, your numerator and denominator will decrease by 1 for each trial. So think numerator, I'm going to abbreviate here, numerator and denominator are decreasing by 1 for each trial. If you have independent events, then you're going to take 1, subtract the probability of not 1 in one trial, and raise that to the number of trials. And that second part of these formulas, probability of none and probability of not 1 in one trial raised to a number of trials, those come directly from the multiplication rule that we talked about in the previous topic. First example. Find the probability of a couple having at least one boy among 4 children. So the probability of at least one boy is equal to 1 minus the probability of no boys. Let's decide, is this independent or dependent? Does the fact that you have a boy for one child affect the probability of having a boy for your next child? No. So these are independent trials. The probability of not having a boy, remember we need the probability of none. So the probability of not having a boy in one trial and then we're going to take that probability and raise it to the number of trials. And in this case, our number of trials are the number of children. So if you don't have a boy, you have a girl, so the probability of not a boy in one trial is still 1/2. Raise that to 4. So 1 minus 1/2 to the 4th is 0.938. Example 2. An unprepared student makes random guesses for the 10 true-false questions on a quiz. Find the probability that there is at least one correct answer. So let's ask ourselves, are these independent? The fact that you answer correctly on one, does that affect the probability that you answer correctly on another? No. These are true-false questions, so answering incorrectly and correctly, you have 50-50 chance, right? So the probability is 1/2 that you do not answer correctly. So the probability of at least one is equal to 1 minus the probability of none. Since these are independent and the probability that you don't answer correctly is 1/2, we can find the probability of none by doing 1/2 raised to the 10th. And 1 minus 1/2 raised to the 10th is 0.999. Now, on example 3, find the probability of selecting at least one blue marble from a bag of 5 blue and 4 green when 3 marbles are selected. And these marbles are selected without replacement. So, when we select these, these are going to be dependent events. The fact that we select the first one is going to affect the probability that we select the second one. So what we have here is the probability of selecting at least one blue. So that would be 1 minus the probability of no blue. So 1 minus the probability of no blue on 3 trials. Okay, so if we can't select blue, notice we have 4 green. So that would be 4 out of, we have a total of 9 marbles. Now we don't replace that marble, so on our second selection we only have 3 green and 8 marbles. And then on the third selection we would have 2 green and 7 marbles. And then when we do that calculation, we multiply those fractions together. That gives us 1 minus 24 over 504. And figuring that and rounding it to 3 decimal places, 0.952.